Normal distribution.
So what are the characteristics of a normal distribution? That is, what are the features? What are some of the things we've discussed or that we know about normal distribution? So that will form a basis for the topic we are going to look at today.
Yes, I think according to what you told us last time.
Yeah.
Okay, but normal distribution. That normal distribution have some properties or characteristics, features or characteristics.
Yeah, which are?
That is,
Just mention some of them.
say deal with mean and symmetric in nature.
Okay,
I
symmetric.
have curve nature, I be curve.
Okay, what's the shape?
That is also deal on
What's the shape?
huh?
Okay, just go on, please. You said
Curve.
you said it's symmetric in nature. That's correct, yes.
Yes, sir.
So what else? What's the shape?
The shape.
You were saying something about
Is
the shape.
curve, Navi.
Okay, bell shaped.
Now you have curve shape or bell shape.
Bell shaped curve, yes. Okay. Okay. Thank you. Thanks. Thanks for that. Any contribution to this? Let's just say something. So even if it's one thing, let's say something about normal distribution. Anything at all will suffice. Anything at all. I know we have some information about it, so let's review that as basis for what we are going to look at today.
Hello, sir.
Yes, please. Please go ahead if you want
Hello,
to.
sir. Yeah, in normal distribution, you also
Yes.
taught us that the mean is 0, while the
Okay.
standard deviation is 1.
Okay. Yes, thank you. So in a standard normal distribution, mean is 0, standard deviation is 1. Yes, thank you. Any other thing about the normal distribution? Of course, that is called standard normal distribution. Standard normal distribution. That's where you have mean equals 0 and standard deviation 1. Why do you think the mean is 0 and the standard deviation is 1? Why do you think so? Now, the mean is 0 and standard deviation is 1 because in a standard normal distribution, the scale, that's the x-axis, the way it is structured, it is based on z-scores. So that 0 we are talking about is actually z-score. When you convert the mean to z-score, you get 0, of course. When you convert mean to z-score, the answer you get is always 0. Last time we talked about data normalization, isn't it? And then we talked about, as we were dealing with data normalization, we dealt with z-scores. Are we following? Are we there?
Yes, sir.
Yeah.
Yeah.
Yes, sir.
Yes. So we talked about z-scores. That's why. Let me show it to you. Now, if you look at this now, what is the mean here? What's the mean? What's the mean height? Please, let's respond so that we can move on
The
quickly.
mean is, I think it's 175.
It's 175. Yes, that's the mean. But you can see 0 is also written here. Okay? This is the actual mean, 175. But this is the z-score equivalent of the mean, 0. When this 175 is converted to z-score, you get 0. Okay? Here, the standard deviation is, if you subtract this 175 from 182, you get whatever the standard deviation is. Are you following? Do you understand what I'm saying? Please, do we understand?
Okay, so we're trying to follow. We're following up now.
Yeah, so if
So,
you
okay.
okay, for example, let me ask you 182 minus 175, what was it? What do you get?
182 minus 175. He give you,
What was it?
okay.
Is this, did I hear 7?
Yes, sir, it's 7.
7, okay. Then 189 minus 182 is what? Also 7, isn't it?
Yes, it's 7.
Try to follow. I'm trying to help you to understand the structure of this thing, the meaning of all these things we are seeing here. You know, as a data analyst, you should have understanding of some of these intricacies. Now, if you now look here now, look at it again. 196 minus 189 is what? 7. Okay? If you come here, the same thing. 175 minus 168, 7. This minus this, 7. Why? Because what that means is that the standard deviation of this distribution is 7. The mean is 175. The standard deviation is 7. Okay? Now, in z-scores, 1, the standard deviation is equivalent of 1. So from 0, from this place to this place is 1 standard deviation. Here to here is 1 standard deviation. Here to here is 1 standard deviation. Okay? So, a standard deviation in z-score, the value of standard deviation is equivalent to 1. The distance from this 0 to this place, from this 175 to this 182 is 1 standard deviation, which is 7. But that 7 in z-score is 1. Are you following now? So when you say in the standard deviation, in the normal distribution, the standard deviation is 1. That's what I'm trying to explain. It's really not 1. Like here now, the standard deviation is 7. But whenever a standard deviation is converted to z-score, you get 1. Understand? What you get is 1. So that's why we say this curve you are seeing, okay? If you are using this 0, 1, 2, 3, like that, minus 1, minus 2, minus 3, if that's what you are using, we actually call it a standard normal distribution. Not just normal distribution. It is standard normal distribution. Why? Because it has been these values have been converted to z-scores. I hope I'm communicating. Am I communicating?
Yes,
Yes,
sir.
sir.
This is a very important.
Yes, sir.
Yes, sir.
This is a very important topic. This is a very important topic. That's why I really want us to get it. Then in the standard deviation, don't forget, in the standard deviation, the mean is equals the mode is equals the median, and they all lie at the center. Mean, like this one now, you see, if this is a standard distribution, then what it means is that the mean of this distribution is 175, the median is 175, the mode is 175. Why? Because in a standard deviation, the mean is equals the median is equals the mode. And the z-score equivalent of all that is always 0. Okay? So, and we know that we have already, somebody has already mentioned that it's symmetrical, which is true. Which means if you look at this, you split it into two halves. The left side is a mirror image of the right side. They are exactly the same. Okay. So the last time we talked about data transformation, min-max, decimal scale, and z-scores. So you cannot see what this z-scores is, how it relates to standard deviation. So for you to work with normal distribution, you just need a few pieces of information. You need the mean, you need the standard deviation. That will help you construct this whole thing we are seeing on the screen. Okay. Okay, so now let's now move on to talk about the topic of the day, the main topic that we want to deal with, that we are about to deal with now. In this session, we are going to look at central limit theory, skewness, and kurtosis. Central limit theory. In probability theory, we know, in analytics, probability is a very, very important concept. I hope we know that. Probability plays a very huge role in data analytics. In probability theory, the central limit theory establishes that, in other words, it says that in many situations, for identically distributed independent samples, the standardized sample mean tend towards the standard normal distribution, even if the original variable themselves are not normally distributed. Now, what is this saying? What is this saying? What this is simply saying is, sometimes they talk about what they call the law of large numbers. That's why sometimes when you are dealing with some models, sometimes you are told that the model, you may be told that the model is used on small sample. That is a small sample model. Okay. Now, that model may have its own distribution, which may not be normal distribution. But if the sample size As the sample size increases, that distribution tends to acquire normality. In other words, it tends to, begin to behave normal. It tends to begin to approach the normal distribution. So the distribution may naturally not be normal, but with more and more samples, it begins to tend toward normal distribution. That's why, for example, let me give you an example. For example, let's say you are working on something like t-test, for example. Okay. Now, when you are working on t-test, if let me not use that, because since we have not got into t-test, so let me not cause confusion. But the bottom line is that, look at it. It says for identical distribution, independence and for identically distributed independent samples, the standardized sample mean tends towards the standard normal distribution, even if the original variables themselves are not normally distributed. So as when you take a large number of samples, okay, the distribution of the sample means tends to, approach the shape of the normal distribution. That's what they call the central limit theory. Okay. So with the explanation I've given, let's go through it again. Maybe we'll read more meaning to it now. It says, in probability theory, the central limit theory, CLT, establishes that in many situations, for identically distributed independent samples, the standardized sample mean tends towards the standard normal distribution even if the original variables themselves are not normally distributed. Anyway, as we go on, we'll begin to deal with various models. We'll always come back to this and mention it along the line. I think it will stick. We gain understanding of it. Okay. Now, skewness. We talked about the normal distribution before, and one of the characteristics of normal distribution is that it is symmetric in nature. It is symmetric. Now, not every distribution is symmetric. Some distributions are symmetric, some are asymmetric. Asymmetric simply means not symmetric. Okay? Now, sometimes data distributions are some distributions are skewed, either to the left or to the right. That is bent to one side. Like this. Okay? Skewed. Left skewed or right skewed. Okay? Negatively skewed or positively skewed. Skewness is a measure of the asymmetry of the probability distribution of a real-valued random variable about its mean. Now, when we say standard deviation is symmetric, a good way to say it is symmetric about its mean. Are you following? It's symmetric around the mean. The mean is at the center. Okay? So skewness is a measure of the asymmetry of, asymmetry is the opposite of symmetry or symmetric. The measure of the asymmetry of the probability distribution of a real valued random variable about its mean. The distribution is asymmetric when its left and right side are not mirror images. I told you before that in a standard deviation, the right side is a mirror image of the left side. Okay, which means they are just totally identical, like identical twins. A distribution can have right or positive, left or negative, or zero skewness. Okay, so sometimes a distribution can have zero skewness. For a unimodal distribution, negative skew commonly indicates that the tail is on the left side of the distribution, and positive skew indicates that the tail is on the right side. In cases where one tail is longer than the other, rather, in cases where one tail is long or the other tail is fat, skewness does not obey a simple rule. Okay. So skewness if you look at this, one is right skewed, the other is left skewed. Which one is right skewed and which is left skewed? Which do you think is left skewed? Which do
The
you think?
positive is right skew, while the negative is left skew.
Thank you. So don't forget that the direction of skew is the direction of the tail, the long tail. So this is left skewed, which is also called a negative skew. This is right skewed, described as positive skew. Kurtosis. So what this means is this. If you calculate the skewness of data, if you get a negative number, then it is left skewed, which means something like this. If your answer is positive number, then it is right skewed. If your answer is 0, then it is not skewed. It's not skewed. Now, kurtosis is kind of opposite of skewness. Okay. Meanwhile, you can use Excel to compute your skewness by using the skew function. Simply use the skew function. Okay. Then in your brackets, you just select the range you want to calculate its skew. Okay. Let's see if we can just look at that first. Okay, can you see my data? Can you see the data on the screen?
Yes, sir.
Okay, so let's say we want to calculate the skewness of this data. We can do that. Let's use this one. Let's say we want to get the skewness of all these curves now. All we need to do is just go to the end. Simply say equals skew. Then you select the data. So that's the skewness. So is this data positively skewed or negatively skewed? Is it right skewed or left skewed?
It's right skewed.
Thank you.
Right skewed.
The data is right skewed. Okay. Slightly right skewed.